Hello, welcome. I am Fatih Günay, a student of Electrical and Electronic Engineering representing Group 14. I am delighted to introduce our Weather application, which allows use to closely monitor a critical aspect of our daily lives using the knowledge gained in the Python programming and engineering application courses. Weather plays a critical role in determining our travel plans, clothing preferences, time spent outdoors, as well as military and logistical decisions. This application enables users to instantly access real-time weather information for any city worldwide. However, its capabilities go beyond this, as the application developed in the Python language utilizes modern technology to present weather data with a beautiful interface and accurate information. In the background, we retrieve weather data using Open Weather Map API. Tkinter was employed for the user's interface design. Speaking of Tkinter, I would like to briefly mention the fundamental libraries we use in our application. The codes in this presentation include Python libraries that form the foundation of our application. Now I will try to understand the function at the core of these codes. Tkinter library is used to design graphical user's interface in Python. This library has been primarily utilized to create the interface of our application. Next libraries, GeoPy and Nominatum. GeoPy and Nominatum are used to obtain geographical location information. This allows users to input the district name and retrieve weather date, and time zone finder and PIDEs are employed to actually time zone information. This enables users to organize weather data according to the user's local time zone. The request library is used to fetch weather data from the Open Weather Map API. This library allows users to make HTTP requests. The JSON model is used to perform operation related to data in JSON format. It's also employed to convert Python object to JSON format or vice versa. On the other hand, the date-time model is used for performing operation related to the date and time. It contains classes to represent objects related to the date and time, while the date-time model is utilized for the date and time operation. The JSON model is used for data sharing or storage purposes. Now let's move on the next slide. This Python code uses to create a simple weather application using the Tkinter library. The getWeather function establishes the main window of the application and defines its appearance, as you see. Next code, root equal tk. This code create an object of the t class to create the main window. In this main window, next code, root.title weather up. This code set the title of the create window to weather up in this here. For example, if we had written airplane instead of weather up, it will have displayed airplane here. Okay. Next code is root.geometry. Specify the size and position of the window. 900 multiplication 500 specifies the weight and height of the window. Plus 300 and plus 200 specifies the position of the window on the screen. On the screen, we made 300 pixels to right, 200 pixel down. This like that. Next code is root.resizable false. This code control whether the window size can be changed. The first false determines if the width of the window can be changed. The second false determines if the height of the window can be changed. In this case, the window size is fixed and cannot be changed by the users, as you see. And if we had used the true code instead of the false code, we could have adjust the window size, by the way. Next code is root.configures. Set the background color of the window. The BG, I mean background attribute, specifies the background color of the window. The color code, as you see in this here, the color code represents a light shade of blue. The function creates a window, sets the title size, position, resizable, priority, and background color. Thank you for listening to me. I appreciate it. I am passing the word to next friend.
Hello, I'm Sweta. In this section of our presentation, we will be looking at how to get coordination information and use it to find the current time. Here we have created a variable called city. This variable takes the city information from the user through the text file. We assign and store it inside. You see the nomination and geocode method below. These belong to geocode library. They connected to open source website called OpenStreetMap. This website is a website that gives you the city you are in when you enter your coordination information and the current coordinate information when you enter the city you are in. In the nomination command, we have to specify what we are entering for the website so that we can get permission to pull the data. Here we use the geocode function to find our location with the city name we received from the user and save it in the location variable. This is a data set that includes latitude and longitude. Below, we use two methods from the time zone finder library. These are working together methods. Here, by entering the longitude and latitude information into the time zone add function, we find the time zone we are in. Below, using the PyTZ and datetime libraries, we first find the time and then the current time there and keep it in the local time variable. In this section, we need to decide how we will display. We made 24-hour display. If we wanted to use the 12-hour display, we would need to write our code this way. Thus, we found our latitude and longitude and our current time. We are taking this data into a variable using the config command and updating. This section is the most important part of our code. The reason for this is that all the information we use in the code is pulled from here. We got our IP from OpenWeatherMap. Here you can see our personal key. This is the IP we use it. This IP allows us to get daily data. There are different IP types. We place the city variable we say on the previous slide inside the IP. Thus, as the user enters new city names or IP, K will be able to search for a different city. Now, when we copy this IP to a search engine and paste it, we encounter the page we see below. We get a dictionary in front of us. However, as you can see here, the data is mixed up. We don't need all this data. That's why we are splitting the dictionary into pieces with the JSON method we called into OR code with the request library. In this section, we create a variable for each data we want to use from the dictionary, and we start to pull the data we need from the dictionary we call JSON data. The reason 0 is used here is that we are doing a daily weather forecast, but we could also do weekly weather forecast. In this case, there would be a separate weather data for each day of the week. In this case, we will specify which day's weather we want to pull in the parentheses. Here, we also defined the temperature as an integer. The reason for this is that Open Weather Map gives the temperature is Kelvin. Here, we convert the temperature given in Kelvin to Celsius by doing a small operation. Here we create a new variables with config to place the data we defined it above. In the later section of our code, we will place these variables in our interface. We place variables we create with config inside variables we create above and at what we want them to appear with next to them in our interface. For example, we wanted the degree symbol to be next to the temperature. We wanted the percentage symbol to be next to the humidity. We entered them this way. The reason we use the config command here is this. If we don't use the config command, our data will not be updated as follows. This is our interface. If we don't receive data from the user and encounter an error, it looks like this. There are 3 dots. If we have not used the config command here, even after the user enters the city and the information is pulled from Open Weather Map, the 3 dots would continue to appear here. Because we are using the config command, these data are updated and 3 dots are replaced with the information we have pulled. This is the end of my section. I'll leave the word to the next friend. Thank you.
Hello teacher, my name is Serkan Çaptu and I am an electrical and electronics engineering student at Adnan Menderes University. This year, when we learned Python in depth, we were in the 14th group and our graduation project as a group was outlined as a weather application. My topic is the search box of our application. We have developed a system that warns like this. My topic is the search box of our application. We have developed a system that warns us when there is an incorrect entry in this file of code we wrote at the beginning. For example, if you type the name of city incorrectly, you will give such a warning like this. Secondly and mainly, in this part of the code, we create a search box. This code create this search box. We create and active this search box in the lines that I will explain after writing the code to specify place in the shape of the search box. Actually, this lane Sections such as the color, shape, and size of the search text were entered. Then a button that could be searched was placed, and the code was converted into format that could be run by clicking on this button as a photo. This photo. Finally, our search box became active. Thank you for listening.
I am Nurullah. Welcome to slide of my part. This is 8th slide. Here we see in first row that definition of logo image. It is our logo image. This code is the file defined at program in Tkinter library. Then with the second row, we are defined the label of our logo on screen. Then define place of it on screen with third code. In fourth row, we made frame for our code. Then other row, we defined some frame for clock and name with font, color and place. In 9th slide, we defined labels for wind, humidity, discretion, pressure with their font, color and place. Thank you for listening.
Hello, I am Yiğit Bafalı. I will be presenting the final part of our presentation. Here we are displaying the values of the data you see below in the presentation. First, we set the temperature variable. We assign a label to the temperature variable. The label's font is Arial, size is 70 and it's bold. The text color of the label is this coded color and the background color is this coded color. Then we position the temperature variable on the screen at 400 and 150. After that, position the temperature variable on the screen. It's here. We create a variable clock and assign a label to it. Then we set its font Arial 15 and it's bold and its background is this coded color. Finally, we position the clock variable on the screen. It's here. Next, we set the wind, humidity, current condition and pressure. We create variable for these. First, we assign a label to the wind variable. It's here. Placing 3 dots where the data will come to visual appeal. It looks like this for now. Then we set its fonts, background color and text color to white. After that, we adjust the position of the W variable on the screen as X and Y. The positioning of other values is similar, each as shown below. Finally, after our code captures the screen data, it looks like this. These are our sources. Now, I will run the code for you. We write the city for which we want to see the value here. The values for Aydın have arrived as mentioned earlier. The data for the parts with 3 dots comes with the config command and you can see here the values: temperature, time, wind, humidity, description, pressure. I'm gonna write other city, which is İzmir. It's here. Thank you for listening. Have a good day.